Good afternoon, ladies and gentlemen. This is Jason, and I'm the technical manager of SuperMap International. Today, I'm glad to be here to share the SuperMap GIS 10i BitCC technology with all of you. First, the BitCC means the BITCC is the 5 key technologies of SuperMap GIS 10i, which makes SuperMap different with other GIS platform provider. So the BITCC is the Big Data GIS, the AI GIS, new 3D GIS, and Cloud Native GIS and Cross-Platform GIS are the basic to support the whole architectures. So next, I will show you the details of these 5 features to you one by one. The first one is the cross-platform GIS. Cross-platform GIS is very easy to understand, just like its meaning. That means the SuperMap products can not only run on Windows, but also they can run on Windows. They can run on Linux natively, such as SUSE, such as Red Hat, such as CentOS, Ubuntu. And the cross-platform GIS means we can run the GIS server, GIS cloud server on Linux operation system. So that brings us some value, such as the safe and controllable. As we know, even we cannot bind the automatic update of Windows 10 upgrading. So if we use the Linux, that means our system and our GIS data, the spatial data, will be more safe, and the whole system is more controllable. And the second value is the new IT technologies, such as big data, such as AI. They always come from Linux first. So if our GIS platform can run on Linux natively, that means we can always catch the latest technologies from IT industry. Later, I will show you the details of how we integrate the latest IT technologies. And the cost-effective just means the Linux is free. We don't need to purchase the expensive Windows operation system for our system or for our application. And the second feature of SuperMap BITCC technology is the Cloud Native GIS. In SuperMap, we mainly have 4 products on Cloud GIS. We call it as 4 carriages. They are SuperMap iPortal as the GIS portal, SuperMap iServer as the GIS application server. We can use iServer to publish our spatial data and GIS capabilities as service. SuperMap iEdge is mainly focused on the edge computing, and SuperMap iManager is focused on the operation maintenance. It is the GIS Cloud Manager. So this is showing how these 4 products coordinate with others, cooperation with others. Like we use iServer to publish the spatial data and GIS capability, and then we use iPortal as the unified access as the whole Cloud GIS center, and we use iManager to do the operation and maintenance. And on the edge side, we can use iEdge to deploy it near the user side when the network is not good, and then it can, based on some proxy and caching technology, to enhance the performance of services published by the Cloud Center. But what is Cloud Native? The Cloud Native means more elastic cloud, and it has mainly 3 features. The first one is microservice, and the second one is Docker, and the last one is automated arrangement. So just the GIS microservice means in the traditional GIS system, the minimum unit is the single GIS server, and there are multiple services included by the single server. But in GIS, in the microservice, the minimum unit is the services. We just divide the GIS server into different independent GIS service, and then it can help us to achieve from complexity to simplification, and the running unit becomes smaller, and it can achieve the feature of faster deployment. Then after we divide the GIS server into different independent GIS services, we need to use the container to contain all of these microservices. So in this part, we choose the Docker as the container of GIS service. You can visit the website of Docker, hub.docker.com, and find SuperMap products image and download it from this website. And after we split and refine the GIS service and use Docker as a container to contain or to organize all of this service, then we choose the Kubernetes, which is also the new technology of IT, Kubernetes, to achieve the function of management scaling. And it can help us to dynamic arrangement and elastic scaling. The third feature of SuperMap BITCC technology is the new 3D GIS. Talking about new generation of 3D GIS, here I will from three directions to explain to you. The first one is the integration of 2D and 3D. And talking about integration of 2D and 3D, here I divide them into a structure, architecture of 1-3-1. The first one is 2D and 3D integration of data structure. And the last one is 2D and 3D integration of software products. In the middle, there are three main features to support the 2D and 3D integration GIS. So the first one is 2D and 3D integrated spatial data management. That means the 3D model data storage and the 2D spatial data storage. Or in another words, we can store both of our 2D and 3D data into one same database, and they have the same functions like customized business attributes, like the SQL and the spatial query, and the sharing and the security. Then the second point of 2D and 3D integration is the sign construction of 2D and 3D integration, because always we don't have the 3D model already, or we only have we want to convert the 2D vector data to 3D model. Then we can use the Symbolized 3D scene model symbols to create the 3D scene like this, such as this is one model of tree. And in one scene, we only have the 2D points, like the right point it shows, and we can deploy the 2D vector data as 3D tree model directly, and it will show like this. And also, we can easily change the style of this symbol, of the tree symbol. And besides of tree, for the pipeline, we have the same technology, such as this is a Wolf model, and we have the 2D vector data of the Wolf model. Then we can configure the 2D vector data as 3D symbol, 3D model like this, and the different symbol just controlled by the different attributes, such as the type of Wolf, the direction of Wolf, and then to connect the Wolf, we can configure the 2D line as 3D pipeline, and we can show the flow on it. And this is another example of convert 2D to 3D, such as the left side is the 2D vector map, and the right side is the 3D a 3D scene constructed based on the 2D vector. We can see the 3D scene looks very good. And the last point of 2D and 3D integration is the spatial analysis of 2D and 3D integration. First, we can achieve the spatial analysis on 3D, like the 3D measurement, the 3D network analysis, and show 2D analysis in 3D. And besides, we have the spatial 3D analysis, which is GPU analysis, such as the view sheet analysis, the profile analysis, the skyline analysis, the shadow analysis, and the terrain analysis. Okay, this is the first point of new generation of 3D GIS. And the second one is support multi-source data. Besides of convert 2D data to 3D, here there are several important data sources of 3D GIS. The first one is oblique photography. The oblique photography model is generated by the UAV, by drone, and we don't need to manually create the model like earlier, and we just need to deploy the oblique camera inside of the UAV, and the UAV fly around to take a picture of this area. And for one single object, there will be multiple pictures, multiple photos from different angles. Then we can use the software to create the 3D model directly. And yeah, we can say this is the effect or the sample of oblique photography. But the oblique photography has the same problem with satellite image. That is, all the objects are continuous with others, such as the tree is connected with the surface, with the ground surface, and the building is connected with the roads. So how we achieve the function of query, or I want to click the building to get the attributes of it. So in SuperMap, we use the method, we use the solution of, we can overlay the vector polygon with 3D model and then to query a building like this. Besides of only query a building, we can achieve more functions based on the oblique photography data, such as query the attributes, such as the query units. That means we overlay the vector data and give it a height and extension, the bottom height and extension height, and then they can overlay with each other. When we click one of it, we can get the attributes of only this one. So if we overlay it with the oblique photography, that we can achieve the function like for a high building, when we click one of the unit inside of it, then we can get the attributes of this one. And the third one is thematic map. And then and the last one is a spatial query. Okay, and next important 3D data source is the BIM. BIM means Building Information Modeling. I think all of you already know it. BIM is a very important and popular method to design the building, and the architecture designer will use the BIM to design the building. I mean, instead of just using the CAD data. So in the design and the construction stage of a building, the BIM software is very important. It's very useful. But in the operation and maintenance part, GIS is very necessary for one building. Such as in the operation and maintenance, I want to monitor the status of all the devices inside of this building. Such as I want to know the status of this pipeline, then then we can develop a GIS application integrate with this BIM model to achieve this function. And why 3D GIS needs BIM? The first one is important. BIM is one of the important data source, and the BIM can bring GIS from outdoor to indoor. That is, in GIS, we always only have the minimum units of GIS objects is always like one building. But if we integrate the BIM into GIS, that is, we can get the detailed objects inside of the building, such as every door, every wall, every table, every chairs, even every cup has its own attributes in BIM model. And this slide is showing the BIM plus GIS intelligent city management application, such as the road and bridge construction, such as the city design, the project management, and the building operation and maintenance. Upgrades from BIM, we have then we can get the C. CIM means the city information modeling. It is the upgrade level of building information modeling. So in this stage, GIS is more important and necessary because the BIM building doesn't, the only one BIM building doesn't have its geographic meaning, but in GIS we can give them the geographic meaning and put them in right location on a map or on a smart city scene. And the last point of new generation of 3D GIS is support the multi-terminals. The change of 3D GIS terminals is from PC to web to mobile. And from PC side is very basic, but on the website, we use the SuperMap iConnect 3D for WebGL to achieve these functions. Let's take a look. This is on the web browser, and we can show the building, we can show the scene, and then we can achieve a lot of functions. You can scan this QR code to take a look at your browser or your mobile. Okay, and 3D WebGL support full data, such as the oblique imagery, the BIM data, the point cloud, the 3D field data, the terrain data, manually modeling 3D data, symbolic 3D scene, and the underground pipeline 3D data. Almost all the 3D data can be supported on WebGL, on web. And it also supports all the features, such as the functions like regional clip, the calculation, the space analysis, the online configuration, scenario, and visualization, and edit drawing. Then we need to talk about the mobile. Besides of the PC and web, SuperMap 3D technology also supports the mobile 3D GIS. And even we can support the VR, such as this is one of the building. Now we support the VR device of HTC and HTC Vive and Oculus. That is, we can wear the VR device, VR glass, to pretend that we are inside of this real scene. And AR is another method to show the 3D GIS, such as the AR is we just use the camera of our mobile, and then we can point to a table and put the building inside of camera, and we can achieve some functions to see the inside architecture, inside object of this building. It's very amazing. Okay, so in summarize, the true 3D help digital twin city. Now we go to the the next feature, which is the big data GIS. The big data GIS technology system has been released from 2017 by SuperMap. We mainly have two directions to achieve this function, to achieve this technology. The first one is for the spatial big data, and the second one is for the classic spatial data. That is actually the big data has its own definition and meaning, such as the big data should have the features of first it has massive, it is a massive data, and the second it should has a low value. Such as from the mobile signal, the big data collected from mobile signal the data volume is very big, but if we don't dig the value of this data, we can only get a few knowledge from this data. But for the classic spatial data also has a similar feature with big data, such as if we have the spatial data of the land use data of the whole country, then the data volume will be very big. But every piece of data is very useful. So these two directions is, first is for the traditional spatial data, and the second one is for the traditional spatial big data, and the second one is for the classic spatial data. And for classic spatial data, we use the distributed reconstruction of classic spatial data. And there are some distributed spatial data engine to store the big data, such as PostgreSQL, such as MongoDB, and the Elasticsearch, the HDFS, HBase, and the DSF. Some of them already can support million level of data, but even some of them can support the billion level of data. For example, this is a 10 million level of polygon data. We draw a polygon and to query the object inside of this bonds, and we can get the response very quickly. And besides of the big data storage, we also have the big data analysis operator. They are the spatial big data and the streaming data, the classic GIS distributed construction, and the distributed spatial machine learning. For example, this is one real case we did before. We need to use the 22.6 million records with a polygon has 3,500 square kilometers to do the overlay analysis to get the result. And the result will be around more than 200,000 records. And if we use the traditional computing, like use a single machine, which has 32 CPU cores, 64 GB memory, this operation will take us 42.5 minutes. But if we use a distributed computing, like we distribute the distributed environment has 4 nodes. Every node has 4 CPU cores and 16 GB memory. Then we only need 2.1 minutes to achieve this operation. There is 20 times enhance of the performance. And the SuperMap iServer streaming data service is we can collect the data from the IoT layer, such as our mobile signal, such as the social media, such as the GPS device, and we can get them from an IoT layer and import it to SuperMap iServer streaming service. And based on the coming data, we can achieve the function, the filter like attribute filter and the spatial filter. And then we can choose to store the data inside of our data storage, or we can output it to map directly. And the SuperMap iServer streaming data service is based on the SuperMap GIS 10i products and the Spark streaming and the Elasticsearch. And besides of the streaming, this is another example to show the no caching dynamic rendering based on HBase. We can see the rendering. Performance is very good, and the data volume is massive. And besides of the big data storage, big data analysis, we also have a function to show the big data. Because, for example, if we have the data of mobile signal and they are all points data with its own coordinates. So how we can show this data on map? If we only show the point directly on map, then the whole map will be covered by points. Then we cannot see anything. So we need some visualization effect to enhance performance and to enhance the environment, the user experience of showing the data and to get more value of this big data. So there are some effects you already seen, and the dynamic visualization of geographic data is like this. Okay, and the data stream visualization, the real-time display. And this is another effect to show dynamic expression of density analysis. This data is based on the time and position of flight. So we can see with the time passing, the flight the heat map is changing. And the dynamic trajectory of taxis in Chongqing city. Let me show you the video. The Chongqing city is one of the big city in China. And this is showing the taxi data of this whole city. And the 3D expression of great aggregation. Yeah, you can see it like this now. Okay, so as a summary, Big Data GIS is a new engine for smart city. Now let's go to the last part of our topic today, which is the AI GIS. The AI GIS technology system has been released from 2019. But we already start to search this technology from 2 years ago. And this is the architecture of AIGS technology system, but we don't need to read out them. We only need to know there are 3 parts of AIGS. The first one is GeoAI, and AI for GIS, and GIS for AI. So first, what is GeoAI? GeoAI is the integrate AI spatial analysis and the processing. Such as this is the estimation of housing price impacted by infrastructure. And we choose the variables or factors as transportation, education, and medical service to get the result like this. The object detection, this is one of our real projects in Indonesia. As we know, Indonesia is the biggest palm oil export country in the world. So they want to know how many trees they have very easily without counting manually one by one. So we can based on the image data provided from the customer and to detect the palm trees. And the second one is AI for GIS. AI for GIS means AI helps GIS software to improve its functions, such as this is based on the AI camera. We use the camera to point to an object, and it can detect the type of this object directly, and then we can upload this location and picture and the attributes of this object to the cloud based on its position. And this is the AR plus AI measuring, such as we use our camera to walk around and point and pick points in the of this area, and then we can get this polygon, and we can upload it to map. Okay, the third part of GIS of AIGIS is the GIS for AI. GIS for AI means the AI analysis results are placed in GIS for results management, spatial visualization, and analysis. such as this is a spatial visualization for AI. This is a traffic situation monitoring and control system. Based on the AI and big data, we can show the information detected on map, such as from the camera, it can detect the type and number of people of vehicle and show the results like this. Okay, and another one, the real-time AI video recognition platform. Also, we can see the yellow area. This yellow area is the busway. The normal vehicle, normal car cannot use this way. So we can detect that whether there is a car occupy this way and show the illegal vehicle number here. All right, as a summary, the AI GIS empower geointelligence. Okay, so let's take a look at the SuperMap GIS 10i BitCC technology system again. The BitCC means Big Data GIS, AI GIS, New 3D GIS, and the Cloud Native GIS cross-platform GIS. And this is the SuperMap GIS 10i product system provided by us. Like in the center, we can see we have the function, we have the products as SuperMap iServer, SuperMap iPortal, SuperMap iManager, and on the edge side, we have the SuperMap iEdge. And terminal side, we managed to divide them into 3 parts: the PC terminal, the web terminal, and the mobile terminal. Okay, so this is my presentation today. Thank you very much. If you have any questions about SuperMap, please feel free to contact me from this email. Thank you.